Our next speaker is Laura Baker, who's an associate professor in the Department of Internal Medicine, the section on geriatrics. Her talk is entitled, Aerobic Exercise Reduces Phosphorylated Tau Protein in Cerebrospinal Fluid in Older Adults with Mild Cognitive Impairment. It's about dementia and Alzheimer's, I think. But here she is, Dr. Baker. Do you want to hold it?
I like to scare people with my titles. And then it's just, it'll wake you up, hopefully. And so my real title is up on the screen there. It was just a trick, just to see if you were paying attention. So I'm at Wake. I'm over at the Stick Center, and I study how to prevent Alzheimer's disease. Who cares about that in this room? Anyone? Has anyone not been touched by Alzheimer's disease in here? Not. And I don't mean personally. Does everyone in this room know someone with a memory impairment or someone who's battling Alzheimer's disease? Okay. If you don't, you will. Within 5 years, my prediction is you will. The numbers are climbing, and so we're all at a fast race to see what we can do to prevent this disease. My particular area of research is something we all have accessibility to. It's something that we all wish we didn't have to do, but we all know that we should, and that is exercise. How many people have considered adding exercise to their life? You don't have to have done it. How many people are thinking about it? All right, hold that thought. So as we get older, the brain changes. That's no surprise to anyone in this room. The positives, we acquire more information, right? So our knowledge base increases. That's the beauty of getting older. We become wiser. Compared to when we were younger, we can identify priorities better, which can benefit our intellectual pursuits. All right, that's what we hang on to. That's my positive change with age. The negatives, I think most of us in this room, no matter what age, if you're 25 or older, you have started to feel this. But as we get older, there are negative consequences. We have more difficulties remembering new information. We have difficulty remembering names of people and places and things and books. We have more difficulty multitasking. Is any of this sounding familiar to anyone? Okay, good. Then you are among friends. And we have more difficulty thinking quickly. These are all the consequences of aging that's normal for all of us. But aging can have some of us go through the natural process of aging. We experience normal changes. The picture I'm showing you here in the bottom in the gray on the left is, you can't really see them from where you're sitting, but there are two brains here. And it's just a picture of a brain as if you had a slice of the head and it's missing here, gone. On the left is a 25-year-old brain. On the right is an older adult who now is experiencing significant cognitive impairment. And so some of us are fortunate enough to go through life experiencing only the natural, normal, age-related changes in brain. Some of the things that I talked about a minute ago in terms of the troubles we have, these are the normal changes that we experience. However, there's a large growing number of us who experience significant cognitive decline as we age. This is not a natural process by any means. This is a disease. And so, our question is, how do we slow down? How do we prevent? How do we stop? How do we treat this progression from normal, healthy, older adults to a condition that can debilitate us significantly in our ability to live our lives? As Dr. Kachevsky said earlier, our goals here are not to live longer, but to live better, live the years that we have to their fullest extent. How do we help these people? How do we help these people live life in that way to the best of our ability? We were built to move. Yet our culture and lifestyle progressively encourage minimization of movement. We sit more than we do 20 years ago. We drive more than we did 50 years ago. We engage in physically active occupations and leisure activities less now than ever. Older adults are among the least active of anyone. So the minimum recommendation we all hear about from the American Heart Association, the CDC, you name it, get 150 minutes of exercise per week. And this is standard minimum recommendation. This chart here that I have on the right shows, if you can't see anything, the last two bars are what age group? Yes, 65 and older. 65 and older get the least amount of exercise, and actually, on average, in a 24-hour period, 15 minutes a day. 15. Don't make me add up the number of minutes in a day. So, physical activity, we all know this. We've learned this long ago. We know that physical activity protects the body against many conditions and diseases that accelerate aging. Physical activity can restore health to multiple sick biological systems in the body. You may be already convinced that regular exercise can protect against conditions like obesity, diabetes, cardiovascular disease, cancer, frailty, the list goes on. Do you have any confidence now that physical activity can protect your brain as you get older? So this is the question scientists have been trying to answer now for a number of years. What if this is true? So what I have here is a kind of the prelude for why we study exercise. There is a wealth of experiments in animals showing these amazing benefits of regular exercise. Some animals love to exercise. Rats and rodents, you can get them to exercise very easily. Monkeys, good luck. But rats and rodents love to exercise. And we know from these studies that when they exercise on a regular basis, things change magically in the brain. The blood vessels, there's growth in the blood vessels. There's protection of the cells that are likely to die. These cells last longer when there's injury or toxicities around. There's reduced inflammation, and there's less Alzheimer's pathology in the cells in brains. That's amazing. So we get these animal results and we say, oh, we have to try this on people. What if this is a miracle, non-pharmacological intervention? So in people, so far, what we know in some human studies is that there is a signal that yes, it may protect cognitive function as we get older. And most of the work that's been done so far is in healthy, naturally aging older adults, not sick. And we find out that their memory and thinking skills can improve. Their blood flow in the brain improves, but in cognitively healthy older adults. So there's been a number of studies now based, because of these exciting animal and early people studies that want to look at the controlled effects. And I mean, the people going into the studies, they are not regular exercisers, because there may be something different about those people. They may have a different diet, or live in a different part of the country, or live in a less polluted area. These studies, the new studies now that are coming out, are all called controlled trials, where people come in and they're all the same. They're all sedentary, they have not been exercising, and then they're randomized to one group or another. And so this is really the best way to see if it's the exercise and not something else in their life that's impacting the change. So what I'm showing you here, and I'm sorry, these can't see it very well, so let me just tell you very quickly. In the top panel, I'm showing you a representative brain. This is just kind of the mean brain of several people, several participants in a study. And you really can't see much except some colors. You see the colors on the screen? The colors represent, now, believe it or not, the colors represent areas of growth, brain growth, following 6 months of exercise. These people are all sedentary when they started. It's never too late is one message. It's your take-home message number one. It's never too late. These people are 65 and older, brain growth in key regions that support cognitive function. In the bottom panel, the colors, again, show increased activity in a critical brain region that is first compromised in people with early Alzheimer's disease. So these people in the bottom panel, they're all in the gray zone between normal and Alzheimer's disease. They have mild cognitive impairment. So they have an impairment, they're still getting around from point A to point B like all of us in this room. These people, after 6 months of exercise, have increased activity in a vulnerable area of the brain. So we are in a crisis time right now with respect to the growing numbers of people with memory impairment, older adults with memory impairment, and the all-time high number of people with dementia, and Alzheimer's disease in particular. As of 2016, I have pills up here with a big no sign in front of it. So far in 2016, we do not have a medical treatment to prevent or slow this disease. However, we have a number of new promising interventions that are being studied now, and some of them at our Alzheimer's Prevention Center right down the road at Wake Forest, the STIC Center. So we have hope that we'll have something down the road, but right now there are no medical treatments to stop the disease. The one area of focus in our research center at the Alzheimer's Center is lifestyle. Can lifestyle, and in particular aerobic exercise, protect against cognitive decline and Alzheimer's disease? All right, so I'm going to tell you about a study that we've just completed here at Wake Forest. We have a catchy name. Always catchy name is important to a successful trial. Piedmont Triad, Aging, Cognition, Exercise Study, the PACE study. Our question was, can exercise, regular, structured, high-intensity exercise, change the trajectory? Can it slow disease? Can it improve the symptoms associated with cognitive impairment? So all of our people, all of our participants had mild cognitive impairment. They were all in the gray zone. They're all at high risk for developing dementia. So why exercise? The difference between exercise and a drug. Drugs are great for honing in on a target, a biological target, focusing on that target, changing that target to restore health. If that's the problem, then a drug is good. When we have a disease that affects multiple biological systems, we may need a multifaceted approach. And so this is why exercise may be more beneficial for this kind of disease. So our design is one where we have a 6-month intervention. We randomize people to an aerobic training or a stretching group. Stretching is our control. Everyone has mild cognitive impairment. Our outcomes have to do with, we look at proteins in the cerebral spinal fluid. That is the fluid that surrounds the brain, that gives us the closest estimate of what's going on inside the brain. We have brain imaging, where we look at the changes in the structure and the blood flow, and cognitive assessments. I'm not going to go into our intervention, except that you can come talk to me about them later. If people always want to know how much is enough. We can talk about this, but let me tell you that it's 6 months, it was supervised at the YMCAs, it's structured, it's high intensity versus a stretching, and both groups get all the same social interaction. The only difference is their heart rate during this time. So one of our questions had to do with what's in the cerebral spinal fluid. What is the marker? Is there a change in the Alzheimer biological marker in response to exercise? So one of the major analyses that we had, it had to do with looking at tau protein. Now tau is the important protein that plays a role in tangles. You've all heard of plaques and tangles in Alzheimer's disease. Well, tau is the critical protein that's involved in the formation of tangles. So if we can see a reduction in tau protein in response to exercise, it tells us, it suggests to us that exercise is changing the pathology of the disease in the brain. And so what I'm showing you here on your right is that what we found is that with people who are over the age of 70, let's look at the far two bars, we saw a reduced amount of this tau protein, this Alzheimer protein in the cerebrospinal fluid. That's the red bar going down. And compare it to the blue bars, which is the stretching group. In the younger adults, which are the bars on the left, we saw no change. So this is a over 70 phenomenon. In cognition, we see, we can think of these bars as like a sum total of of test scores that measure your ability to plan, initiate, multitask, pay attention, and these kinds of tasks that help you to focus your attention on your environment right in front of you and organize your life. Aerobic exercise, 6 months of aerobics exercise improved cognitive function for these individuals, and we saw a decline in the stretching control group. Remember, all of our people are in the gray zone. We already expect a change for these people, a decline in 6 months, and that's what we saw in the stretching group. Okay, and then the last findings that I'm going to share with you today have to do with the brain imaging. I have two findings to show you. One, I'm showing you in this, again, you can't see it well, but I'm telling you that what I'm showing you in these pictures, that kind of think of them as a mean brain imaging picture, the areas that are circled are areas where we typically see shrinkage as the disease progresses from mild cognitive impairment to Alzheimer's disease. Do you see the yellow circles? These are the areas we typically see shrinkage. The yellow areas are exactly the areas where we saw brain growth in this study. Okay? And then finally, I'm showing you here changes. This is what we're very excited about this. These are all, the colored areas all show areas of the brain where there was increased blood flow. So in the red area, the blue area, and the green area, we saw increased blood flow in the aerobic group, but not the stretching group. Now what's important about these areas is these are the areas, the red area is affected, you typically see a decline in blood flow with normal aging in the red area. We've increased it. In the blue area, you typically see a decline in blood flow with early Alzheimer's disease. We see an increase. So I think my parting words for you are, can exercise protect the brain as we age? I've shown you some evidence to suggest that maybe this is the case. It's up to you to decide. Is it worth the sweat? And I leave you finally with this picture of how to find us. Again, we are right down the road. We work with the community heavily to prevent this disease and identify treatments that are going to add quality of life to those who are losing it faster than we would like it to be the case. So thank you.